friends, welcome back for another video, and if you are new to my channel, don't forget to subscribe the channel and press the bell icon. Today we will discuss about fundamental forces in nature. There are four fundamental forces in nature. First one is gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Now what is gravitational force? It is the force of mutual attraction between any two objects by virtue of their masses. It means any object having some mass will absorb this kind of force by another object having some mass. Next is electromagnetic force. It is the force between charged particles. As we know, unlike charges attract each other and like charges repel each other. When these charges are in motion, they produce electric field and which in turn produce magnetic field. These both fields combined are known as electromagnetic field or electromagnetic force. Next is strong nuclear force. It is the force of attraction between protons and neutrons inside a nucleus. As we know, inside a nucleus there are protons having positive charge. So all the positive charges, since they are like charges, they should repel each other and the nucleus and atom should be ripped apart. But this is not what actually happens. This nuclear force is strong enough to compensate the force of repulsion by the like charges, that is protons. And the last force to be categorized as fundamental force of nature is weak nuclear force. This type of force appears only in certain nuclear processes such as beta decay of nucleus. You may study this in higher classes. What is beta decay? In beta decay, the nucleus basically emits an electron and an uncharged particle called neutrino. This is antiparticle. This particle was first predicted by Pauli in 1931. You can see here a neutron inside a nucleus is converted into proton with the emission of electron and an antiparticle called neutrino. Now we will discuss about conservation laws. Conservation law is a hypothesis based on observation and experiment which cannot be proved. These can be verified via experiments only. First one is law of conservation of energy. According to this law, energy can neither be created nor be destroyed, but can be converted from one form to another. For example, if we push a car, then our mechanical energy is converted into kinetic energy through which the car is able to move. This law is valid everywhere in the universe, and it is believed that total energy of the universe dating from Big Bang remains unchanged. Second is law of conservation of mass. This law states that for any system where transfer of matter and energy is observed, the mass of the system must remain constant over time. This law is basically applicable in chemical reactions where two or more reactants react to give product and byproduct. Mass is also converted into energy by famous Einstein equation E is equal to mc square, where c is speed of light. Next is law of conservation of linear momentum. Momentum is quantity of motion of a moving body. This law states that for a collision occurring between two objects in an isolated system, the total momentum of the system remains conserved. That is, the momentum before the collision is equal to the momentum after the collision. For example, consider two balls, white ball and a yellow ball. The yellow ball is in rest while the white ball is moving towards the yellow ball. Before collision, the momentum of the yellow ball is 0 and white ball is having some momentum. But after collision, the white ball transfers its momentum to yellow ball and comes to rest while the yellow ball starts moving with the same momentum transferred by the white ball. Hence, before and after the collision, the total momentum of the system is conserved. This was all about today. Thanks for watching. Have a good day.